All right. Let me just make sure. Carmen, are you out there in La La Land? Aiden Cash and Melendez, you're there, right? Logan?
Yes, sir, I'm here.
So it's just Cash or Carmen. I don't know if they're using a name. If not, there's Mr. Garcia. There's Mr. Garcia, I know he's here. Okay, so let me do a couple housekeeping chores, a couple of takes a few questions, and then we'll jump into it. Let's see. Let me see. And if someone texts you, tell them to use that's trying to get in and I won't let in, tell them to use their real name. It's got to be either Mr. Carmen or Mr. Cash. We're supposed to let you in if you're using some kind of fictitious name, just because we've had a couple issues in other classes. Okay, there it is. Mr. Cash, were you using a different name, like Herbie Jablon or something? I guess I need to re-go over the. That's him. Let me go over some of the policies too on Zoom and Zoom classes. It's similar to classes. If I had them, yeah. Actually, I've got them on the board. I didn't notice it from the other day.
You don't gotta do that.
Let me just bear with me 1 second again, just because we've had let me go over a few things on the Zoom. All right, you got to have your video on, or I technically can kick you out. Okay, you got to have your video on because there's been some Zoom bombing issues and some legality issues that we're trying to eliminate. So make sure your video.
I don't have a camera, sir.
You got Zoom bot? You got Zoom bomb?
You can.
Sir, what if I don't have a camera?
I think you can do it on your smartphone, can't you?
No, I can't download apps. What I'm saying, like I'm on my laptop. No cam.
No camera on your laptop. Well, work on that now when we come back after Easter, because otherwise I'm gonna.
Should I like get a webcam, or should I just like?
You can buy an extra. I know some of the teachers here buy a little camera. They just hook into a USB port. So that might you can probably get a real cheap one, $10 or something. I don't know. No food,
Like
no water,
$70, y'all.
no hats, no do rags. Okay, that's all part of your rep grade.
Why I can't with my
It
do
doesn't
rag?
matter what we wear.
Can't be in bed. You have to use an actual username. Mr. Cash, if that was you going in under Herbie Jablon or something else, I'll let you in.
Why can't I wear my do rag?
No.
That's the rule. I mean, if you want to violate the rules, that's fine, but just don't come whining and complaining to me about your rules that they've asked us to enforce. Same rules I put up on Monday. So if you want to do your own thing, that's fine. Don't come crying to me about it. Okay. All right. Check behind the Word pod. Hopefully everybody submitted the.
Hey.
Hopefully everybody has submitted the quiz from that was put up on Monday, yesterday. All right.
Did you see that?
Hey.
Yeah.
Dude, Aiden Cash is wildin'.
Hey. That's just not me.
Aiden, what are you
What's up,
doing,
AK?
man? Why's your name AK, bro?
That's just not me.
Just gave.
AK?
All right. I can mute everybody.
Bro, what you doing?
Okay, Aiden, if you would turn your video on, so I don't have to.
Sir, that's not me.
My camera is broken on my computer. I need to fix it.
All right, who signed on as Aiden? AIDAN. I'm going to remove
Sure.
you.
I need to
Yeah,
fix my camera.
that's some weird
That's
person.
not
Hey.
me.
Hey, it's Aiden Cash. I don't know who Aiden is.
That's just
Aiden, okay, You'll be
Sir,
leaving
do you
the
not see me?
AIDAN. Listen up. Stop the talking. AIDAN. You're going to be removed here. All right. If you don't say who you are and turn your camera on.
Sir, there's two of them.
All right. You're gone. See ya.
Oh,
Hey, Jeffrey, can you please? I need this credit. Jeffrey, I need the credit. Jeffrey, please don't kick me. I need this credit.
This guy's soft. All right. We'll take care of him. Nice thing about the new Zoom, we can kick people out.
Come on, Jeffrey, please. I need the credit. Please.
Sir, why would you kick Aiden Cat?
My mom's going to beat my ass if I don't get a good grade in this class. I need the credit.
She should.
I need the credit. Please leave me in here. I need the credit.
Let's see, who else can I get rid of? All right, I think we got rid of all the infiltrators.
Sir, that was not me.
What's up with
Okay.
that?
Who was that actually?
Well, they're wasting your valuable, we only got 50 minutes twice a week, and they're wasting some valuable time, so.
Mr. Gaffney,
Oh,
did you
wait,
see
it's
my
not fun.
you see my email?
I've not checked emails in the last couple hours because I've had two other classes.
I sent you my 5-2 problem set 1, like just recently.
Okay. All right.
I just want to let you know I turned it in.
Okay.
Mr. Gaffney, can I get a use the restroom real quick?
Oh, okay. So again,
Not use the restroom, thanks.
that's part of your rep grade. You know, being in class on time, not being rude, disruptive, disrespectful. Video needs to be on. If you don't have a video camera,
Mr. Gaffney,
between now and then. So Mr. Melendez, Mr. Myers, Mr.
Mr.
Lane,
Gaffney, you accidentally kicked out Isaiah.
you can try to log back in then. All right. If he was using some kind of.
It won't let him because you blocked him out.
All right. Let me. What name is he using?
Isaiah Walker.
Oh, he
It's
was.
Isaiah Walker.
See, this is just wasting valuable time.
Free my boy Charles, bro.
Let's see if
Cool.
back in.
Let me see the jumps.
I took the right one out again because the girl put it in wrong. She did like a really jacked up thing. I saw this.
Nice.
Mr. Gaffney, do you like my ear?
That's just
Well, you're kind of gay for that.
wonderful.
Yo, I will kill you, Lansness.
Let's sneeze. Timmy.
You're dead.
Let's sneeze.
Let's see. I'm trying to see if I can find him. I don't see him in the list here. Where...
Timmy, how's the bowl cut?
It's going good. I'm growing it out. It's getting extra long, dude.
Hey,
I wish I had a camera to show it off, but
Oh my gosh.
you know,
just snap me.
that's true.
All right, I gotta go.
Okay, so here we go. Can't really help Mr. Myers. He was under some kind of fictitious name, so if he wants to come back in, just tell him to try to come back in.
No, sir, you kicked out Isaiah Walker, not Gabe.
Okay, let's see, let me look one more thing where he could be.
I'm right here, sir.
Okay, I got you. I hate to waste a bunch of time doing this, but give me 1 second here, see if I can find out. Nope. Well, just not get him back in. Anybody know who Michael is?
It might be Morrissey. I don't know.
Yeah, there's no Michael in this class. I think.
It might be like Michael Morrissey. I don't know why he'd be in here.
Yeah, he wouldn't be in here.
Okay. All right. So If you, the deadline yesterday was to submit the quiz for 5-1, so hopefully you put it in Dropbox. If you had a Dropbox issue, I'd rather it be there, so it's there collectively, and hopefully you did it before last evening. I think 9 o'clock was the deadline date. And if you didn't do it by then, still do it. You'll lose a few points for not being in time.
Oh yeah, Mr. Gaffney.
Yeah.
I couldn't. My computer's messed up.
It seems to be working okay now, right?
Like my Dropbox. It wasn't letting me Dropbox it. Anything.
Okay.
Put it on YouTube.
Then send it to me.
I don't even know.
Send it to me as in the email. Okay.
Email. Okay. Okay. I have a lot of stuff to send as an email.
Yeah. Okay.
Mr. Gaffney, Isaiah wants to talk. He's right here.
Why am I out the like? Why you hit me at a thing like it wasn't even me?
Well.
Like you saw my camera, right?
There was a couple people in here that weren't supposed to be in here.
But you saw me on the camera, though.
I'm not arguing that point. Okay.
But I took off my do-rag in front of you. Like, why am I at the party?
You're out of the party. You can try to come back in. I can't. I don't know.
I can't. Like,
once I remove.
Because I can't because you kick me out. I can't. You blocked from the
No,
thing.
I don't want you to waste any more of my time. All right. If you want to put it your phone. If Mr. Cornett's nice enough to put the phone there, you can listen that way. But I can't retrieve you once I remove you. All right.
So why did she move me in the first place then?
Because there was 3 people in here that weren't in the class, and somehow you got lost in the shuffle. It was inadvertent. I apologize for that.
The shuffle, what? I was the first person to join your class. I was
Mr. Cornett, mute him, okay? I'm not going to waste any more of my class time with him. All right. So grab problem set number 1 from Monday. Okay. Grab problem set number 1 from Monday. All right. I'm going to do a quick review problem on 1, and then I'm going to show you the answers for the 6 other problems that you were supposed to do, so you can compare in that. And then if you have access to Blackboard, I entered earlier today the problem set that we're going to use. And then just make a note, I'm going to also enter an additional problem set that has the explanation, because I can't put more than one document in a Dropbox at a time. I'd love to do 2, but I'm going to teach you 2 ways to divide polynomials. Long division way, which students typically struggle with because you're not taught long division much anymore with the advent of calendars. And then I'm going to teach you a synthetic way so that you can see them both. Now, if you were good in long division, you probably want to use that method. If you weren't taught long division or weren't good at it, then you probably want to use synthetic. It's a little easier, a little more mechanized, a little simpler. So you're going to learn both of those today. Pick the one that you're most comfortable with, all right?
Sir.
Yeah.
I have my problem set done here. I just emailed it to you because I keep forgetting to do that, but I have it done right here.
Okay, email it, or I think wasn't there a Dropbox for that too?
Not up yesterday because I turned 2 things in yesterday, and that was the quiz and something for chemistry, and there was nothing else.
Anything else? Okay.
So I just kept it here, and I thought it was like I'll talk to them about it tomorrow.
All right, so we'll use number 3 as a refresher, and then I'll give you the answers for the other 5 or 6 problems. All right, so you had 60a squared times b cubed minus 48b to the 4th minus 84a to the 5th b squared. Pretty complex problem, but as we talked about on Monday, each one of these components of this polynomial are each individually divided by 12ab squared. All right, so you could theoretically, kind of divide this into 3 segments, with each one of them being divided by 12ab squared, right? Hopefully that's the way you did it, all right? So if we divide 12 into 60, we end up with 5, and we have a squared over a, which a to the squared over a to the first leaves an a, all right? And we got b cubed over b, which is b. All right, so it's 5ab is the first part of it. So that takes care of this part. The next one is negative 48 divided by 12, which is a negative 4. All right. There's no a in the numerator, but there is in the denominator, so it just kind of rides and stays as is. And I got b to the 4th over b squared, so 4 minus 2. I got 4 b's on the top, 2 on the bottom. That leaves a b squared in the numerator. All right. And then the last one is negative 84 divided by 12, which is a negative 7, I think, right? We got a to the 5th over a, so that leaves a to the 4th. And we got b squared over b, which leaves 2 minus 1 is 1. So it should be 7, a to the 4th. Actually, this was b squared too, so the b went away.
How is it 12ab squared?
12. And
Should it be?
that's what we're dividing by, right?
No. The first, like.
Well, I just kind of rewrote it 3 times because each one of these was divided by 12ab squared, right?
Yeah, but like, how is 60? Oh wait, no.
Here's the this came down to here, this came down to here, and this came down to here.
Okay, I was confused. All right.
Make sense? Other questions? Any
So if the a is under just one of them, so like it would be the 4b squared. Like, do you keep the a under for like the rest of the division?
Yeah, because there's no a up here, so it just kind of rides or stays as is. There's no a to subtract from it in the numerator, right? So
Okay.
it just holds its place, right?
So do you just keep the when then you divide 84 by 12ab squared, do you keep the a on the bottom or do you do the entire thing?
Well, you realize that all of this is divided by all of this, right? So since there's an a on the bottom that I have nothing to address it with in the numerator, it just kind of stays as is, right? It just stays where it's at. You can't arbitrarily move it, right? Otherwise you've changed the problem. There's nothing that would make it move.
All right, thank you.
Any other questions on that? If you got that one right, that's probably one of the more complex ones.
Where's this problem from? Like, where's it at?
This is the problem set from Monday. Now, we did 7 or 8 of them by hand, 6 or 7 of them by hand copy, and then Monday, sometime during the day, Monday, I attached it in Blackboard. And you were supposed to finish the other 7 or so that we didn't do in class. It should be Monday's Blackboard. Okay, I'm going to slide down and I'll move it down here in a minute. But here are the problems. Here are the remaining problems that we didn't do in class with the corresponding answers. So I want you to take a couple minutes and just go down the line and look at these answers, reference what you came up with, and I'll scroll down more down below it. And then if there's a question or two on them, I'll go back and address or answer those. Are you guys telling some of your buddies to try to come into this class?
What?
Are you guys telling some of your buddies to come into this class using fictitious?
No, I don't have friends.
Robbie, I'm your friend.
Hey, thanks, Fred.
Oh, yeah, I'm your friend too.
I'm going to slide down here in a minute. Anything on like 4, 5, 6, and 8 that we need to talk about? Anything on 4, 5, 6, and 8? Any questions? Take a look at those answers versus what you came up with so we can clear those up, because we're going to kind of jump into a different way of dividing polynomials here in just a few minutes. Hearing no questions, I'm going to scroll down, move down just a little bit. There's, come back a little bit. Let's see if you can see that. 14, yeah. Here's 8 through 14. And compare your work versus these answers. Are we getting these answers?
Yeah, I'm perfect so far.
Can you do number 10?
This is slight, sir.
10. All right, let's see. I'm going to come over this way just a little bit. Let me write, while you're looking, I'll try to get both on there while I'm putting the problem. Okay, let's see. Can you see that? I'm going to maybe do it in black so it shows up better. All right, I'm going to back up a little bit. Is the numbers big enough to read?
Yeah.
See that? Okay, number 10. All right, so we're going to divide. I'm not going to write it 3 times. We're going to divide -30 by -6. That's a +5, right? And we've got x cubed over x squared, which leaves an x. And we've got a y on the bottom. That match up so far? No. Where's the y at? Let's see. X cubed. Oh, there is a y. There should be a y right here. So there is no y in the bottom. I miscopied it. All right, so 5x for the first component. And then we got +12 divided by -6, which is a -2. We've got x squared over x squared. So anything over itself always equals 1. So that equals 1. And I've got y squared over y. 2 minus 1 is 1y in the numerator. All right. And we got -18 divided by -6. All negatives. So we got +3. The x squared is equal 1. And the y is equal 1. So there's our final answer. Good. I'll come, I want you to see both. Anything else we need to talk about on those? If you didn't do these, at the very least, jot these answers down, and then hopefully sometime over the 10-day break, whatever, how many days it is, put these problems and make sure you get to this correct answer. Okay, so now we're hearing no questions. We're gonna change, well, not change course, but we're gonna do a different type of dividing polynomials. All right. Who learned long division in probably middle school or maybe late elementary school? Long division being, let's say I was going to divide 8 by 3 or 36 by 8. Remember that, long division?
Yeah.
Didn't get taught much once calculators came out. So we're going to divide 306 by 8. So we go 8 into 30. So that goes what? 3 times, right? 3 times 24. We subtract the 24 from the 30 for 6. We now have 66. Now we divide 66 by 8, which is 8. And that comes out to 64 with the remainder of 2. So we have 38 and 2/8, which I'm going to simplify to 1/4. It's 38 with a remainder of 1/4. There's 1/4 of an 8 that goes into 306 after the full 38 times 8 goes into that. Who was taught long division? Everybody? Okay. What we're doing on problem set 2, the problem set 2 online that if you've already downloaded it, teaches you long division. I'm going to kind of put a little bit of the cart before the horse because problem set 3 teaches you synthetic division. I'm going to go through a couple of these and teach you both. You pick the one that you like the best because they both accomplish the same thing. all right? If you're good in long division, you may want to stick with it. But I'm also going to teach you synthetic division. And the rules and policies of how to do synthetic division are on the top of problem set 3, and I'll load that up either later today or tomorrow, okay? So, any questions before we jump into this? So if you didn't print that out or haven't printed it, can't print it out, or, you know, we're going to divide 2x squared minus 5x minus, we're going to divide a polynomial by polynomial.
Mr. Gaffney?
Divide that by x minus 3, and there's the setup, right?
Mr. Gaffney?
Yes, sir.
Is this problem set 2?
This is problem set 2.
Gotcha. I'll have to get that out. Let me look for it.
Okay, so thinking in terms of long division, what we want to do is take the kind of the first component of each polynomial and start eliminating kind of zeroing these things out from left to right. So what we're really doing is we're going to divide x into 2x squared, right? This is technically what we're doing. We're going to divide, if I divide 2x squared divided by x, that equals what? And you don't have to do this. I'm just using this for an explanation purposes. How many x's are in 2x squared? There's 2x, right?
Yes.
Okay, so there's 2x in there. So you put like terms over like terms. So I'm going to write a 2x right here, okay? Just like we did that kind of simplified long division, all right? So now I'm going to start the long division. So I multiply 2x times x, which gives me 2x squared, which is what I want. I want to zero these things out. And then 2x times negative 3 is a negative 6x. Everybody with me so far?
Yep.
If you did long division, this should ring a bell. Okay, so now I'm going to subtract the bottom row from the top row. All right? So 2x squared minus 2x, that zeroes out. All right, there's nothing left. Negative 5x minus a negative 6x is the same as negative 5x plus 6x, right? So there's an x that comes down. Still good? Then the negative 3 just comes down as written, okay? So how many x, so now I'm going to divide this by this. How many x's go into x?
1.
There's a clue. All right, so it's a positive 1, right? So I'm going to 2x plus 1. So 1 times x is x. 1 times negative 3 is negative 3. And then I'm going to subtract again. X times x zeroes out. Negative 3 minus a negative 3 is the same thing as negative 3 plus 3 zeroes out. So that 2x squared minus 5x minus 3 divided by x minus 3 equals 2x plus 1. That's long division. There's my final answer.
Okay.
Questions? That's long division. May ring a bell depending on what you were taught. So let me now do the exact same problem, and I'm going to show you some. It's kind of nifty. The rules and instructions is kind of in a nice little kind of flow chart on problem set number 3, and I'll load that up after class today, okay? So here's the exact same problem, 2x squared minus 5x minus 3, all right? Everybody with me? All right, so what we do, I'm going to take the coefficient of each one of these. So I've got 2, I've got negative 5, and I got negative 3. Now you got to make sure the variables and the exponents are in sequence. 2, 1, 0, right? If it skips, and we're going to do this in a problem 2 down the road, if it skips a sequential exponent, you've got to put a 0 in for a placeholder. So all I did is I took the coefficients. Everybody good so far? Now we're dividing by negative. Our divisor is x minus 3. So we're going to take the negative 3 and we're going to reverse the sign. All right. So now it's positive 3. And you might want to make a little box.
What number is this?
This is still number 4. I'm solving it the exact same way, but this is with synthetic division. Okay. All right, so we draw a line and leave a space. Let's see if you can see that. Yeah. Okay, so the 2 comes down exactly as written. All right, so here we go. 3 times 2. Let's do this. We're going to multiply this. We're at 3 times 2. It's going to go up there. 3 times 2 is 6. Okay. And we're going to add these as opposed to subtracting like we did in the long division. And the reason we're adding and not subtracting like we did up here is because we reversed the sign of that -3. So we got 3 times 2 is 6. Now we add -5 and 6 is 1, right? 3. Now we go 3 times 1. And it goes up here, which is a +3. -3 plus 3 is 0. Okay? So what we just did, we divided by the second half of that divisor, the -3, but we never addressed dividing by the x. And the way we address that is we now then slap the x's on these using one less exponential power than what the initial part of the equation has. So this now becomes 2x plus 1. And there's our exact same answer that we had earlier. I just added the x to here. And that's what by doing so, I'm really dividing the x's into this of that, where were we? Of the x minus 3 divisor. That make sense? Yes?
Yes.
All right, I'm gonna go a little faster unless there's a question.
I have a question.
Go ahead.
So, if we did that method and it was x plus 3 instead of x minus 3 to begin with, would we still have reversed the sign, so you're subtracting?
Always reverse the sign. And the reason that I didn't create this model or methodology, the reason you do that is then you add these columns. If you don't do that, you would subtract it. So there's a nice explanation on problem set 3, which I'll load up here later on today that you'll have to do over the long break. All right, so here's a similar problem. Let me tilt it up just to here so you can see it. Any questions? All right, so we got m squared minus 3m minus 7. This is number 5 in that problem set, divided by m plus 2. So here's our divisor. Here's what's being divided. Long division, right? How many m's are in m squared? There's 1. And so you always put the like variable with the like exponent on top of each other. All right, so we go m times m is m squared. M times 2 is plus 2m, right? Now we subtract. Right? So m squared minus m squared zeroes out. -3m minus 2m is 5m. The -7 now comes down. All right? How many m's are in -5m? There's -5, right? You see this matches. No variable, no exponent. All right? So -5m is -5m. -5 times 2 is a -10. And once again, we're going to subtract. So -5m minus a -5m is just like adding, so that zeroes out, which is what we want. We got -7 minus a -10, which is plus 10. So we've got a plus 3. So our answer is m minus 5 plus 3 over m plus 2. That 3 over m plus 2 is our remainder. That makes sense? There's no questions, and I'm going to show you the synthetic method of doing this. Again, you don't need to do it both ways. Pick the one that you like the best. All right, so the coefficient of m squared is 1. The coefficient of -3, m is -3. The -7 comes down as is. All right? And we're dividing by m plus 2, so we take the opposite sign, it's -2. Let me back up and come around just a little bit. All right, draw a line, the 1 comes down, right? -2 times 1 is a -2. -3 plus -2 is -5. -2 times -5 is a positive 10. -7 plus 10 is a positive 3. Now I put the variable and the exponent back with one less exponent. So we have m squared, so we're going to start with m. So this now becomes, I'm going to do what I tell you not to do. It's 1m minus 5 plus 3 over, what was our divisor? M plus 2. I'm going to remove that 1 now because it's redundant. So there's the answer, which is the same thing as we got up above there.
We can't see.
You can't see? Let me zoom back so you can get the whole, if I'm going to make it a little on the small side. So you can see both methods.
Where'd you get the -2 from?
-2. Okay, let's see. Because remember, the 1 came down. -2 times 1 is -2.
No, where'd you get the -2 in the box from?
-2. All right, because we're dividing by, the initial one was m plus 2. Remember, we take the reverse sign of that. Okay, take the reverse sign. And which allows, I think the reason, because I didn't invent this process, I think the reason that that's done is so that you can add this. And typically you're going to make less errors or mistakes by adding versus subtracting. That makes sense?
And how do you do the M part after you get all the numbers?
Okay, so this became m. We put the variables back on with one less exponent that we started with, because by doing this, when we did this -2 and all stuff, we're just dividing by 2. We hadn't addressed also divided by m. And you do that by just taking one less exponential power of the variable. Okay, now, so we got m minus 5, and here I got, this is a leftover, this is a remainder, right? Because it doesn't go fully into it, just like up here. And so we put that value, whatever it is, over the divisor of m plus 2. Make sense? Remember when I did a problem when you divide something into something, whatever the remainder is, it's like over 1/3 or over 2/3. If 3 doesn't fully go into that number, it's a remainder. All right, let me show you one last little trick or problem. All right, let's look at this guy. Let's see. Let me make sure you can see a little bit. I'll scroll down. All right, this is number 6. It's p cubed minus 6 divided by p minus 1. All right. So this is one of those scenarios where there's no p squared, there's no p to the first power. So you got to have, I call them placeholders. I'm not sure what, I didn't look at the con video or the JMT video, but you got to have placeholders. So the long division method, here's the p minus 1 or divisor. You've got to put a placeholder, and I just use 0. So it's p cubed, and I just put 0 and 0. I put the 2 and 1 there because we don't have a p to the second power or p squared. We don't have a p to the first power. Here's the -6. You need those placeholders to execute the long division. All right? How many p's are in p cubed? It's p squared, right? 2 p's. So here's my squared kind of placeholder. So I put everybody see it? I put my p squared right here. P squared times p is p cubed. P squared times -1 is -p squared, right? I draw a line. Remember, these were subtracting. The synthetic were added because we reversed the sign of that. All right. So p cubed minus p cubed zeroes out. 0 minus p squared now becomes a positive p squared, and the 0 comes down. That'd be good?
So the 0, what does the second one say?
I just put 0, I just put to the power of 2, just to remind you and remind me that that's a placeholder because there is no p squared.
Okay, yeah.
All right, so now I've got p squared. How many p's are in p squared? Just 1. P squared over p is p, so I'm going to put that right here because it's p to the first power. That's my first power placeholder. P times p is p squared, which is what I want. P times -1 is a -p. All right, p squared minus p squared is 0, which is what I want. 0 minus p now becomes a positive p. P into P goes 1 time, so it's +1. So 1 times P is P. Oops, and the negative, I'm sorry, the -6 comes down. So 1 times P is P. 1 times -1 is a +1, right? So now I got P minus P, zeros out. -6 minus 1 becomes a -7. So my final answer is P squared plus P plus 1. I've got a remainder of -7, so it's -7 over P minus 1. This little thing here, that's my remainder because it doesn't fully divide evenly. The big thing
Why is it plus
you've got to
1?
check. You've got to check to make sure you've got every exponent accounted for in sequential order from left to right.
Why'd you put plus 1 and not -1 for P plus 1?
Let's see here, because I needed 1 times P to get P. All right, because it was how many? What does P over P equal?
1.
1. That's where that came from. Other questions? All right. So let's do it synthetically. All right. Let's see here. Let me just make sure I don't do anything out of the ordinary. All right. So synthetically, let me come down just a little bit, and I'm going to step to this here. All right. So now the coefficient of P cubed is 1, right? I don't have a P squared. I don't have a P to the first power. And the next in sequence is a -6. Almost similar to what you did up here, right? My divisor is P minus 1, so this becomes a +1. Everybody good so far?
Yep.
All right, so the 1 comes down as written, so 1. 1 times 1 is 1, all right? Let's see here, let's see. And we're adding, right? We're adding, we're not subtracting like this, like the long division, all right? So 0 plus 1 is 1. 1 time, you can kind of see what's happening here. 1 times 1 is 1. 0 plus 1 is 1. All right. 1 times 1 is 1. Let's see. Is that right? Or did -6 plus 1? Did I mess up on the signage? Yeah, I missed. I'll come back and fix it. -6 plus 1 is a -5. I'll come. I know what you're going to say, but just give me a second. I'll come back and fix my mistake. All right. So we started off with P cubed. So this becomes P squared. This becomes P. All right. And we can. I'm going to remove the ones. So we got P squared plus P plus 1 minus 5 over P minus 1. Now you say, well, those two answers don't match. And the reason they don't match is a mistake up here. Because let's see, we brought, where did I cut corners at? Let me see. Oh, I know, because, let's see here, I erased it, but I hadn't, so I brought -6 down. P, -6, I think, right? Yeah. So then add P minus 1. So it's -6 minus a -1, so it's -6 plus 1. So this actually should have been a -5 up here also. So it was a -6 minus a -1, so it was -6 plus 1. So up here, and I'm a little above the screen though, it should have been a -5 as opposed to a -7. You know, like I said, most in previous years when I've taught this, most guys like the synthetic better. So they both accomplish the same thing. I'm not going to hold you to one or the other. You need to know how to do one of them. All right. Careful on problems. Always check before you get too far into it, or as you set it up, that each exponent is accounted for. Otherwise, you're going to create a folder. All right. So we did on problem set 2. We did 4, 5, and 6. 3 more on there. And if you give me a minute or give me a little bit of time, I'll load problem set 3 and work on that between now. We don't get back together again until like April 20th. Work on have both of those done have the second one done, or the one problem set 3. I'm going to put that in a Dropbox. Just have that done by Sunday, the Sunday before we come back, which I think is around the 20th. So I can see that you're doing it correctly and see if I need to spend any time on it. And the nice thing about problem set 3, it has kind of a nice sequential step-by-step process for what I explained, but they go into verbiage on what and why and where to do each step. Any questions?
So problem set 3 is due Sunday.
Oh, well, it's a week from Sunday because I won't see you again till, all of next week. I don't see you guys anymore this week unless you want to check in office hours and pick up 10 points towards your rep grade. So I won't see you again until a week from next Monday. So about, 10, 11 days from now? I didn't really look at the calendar that close. So problem set 2, you only got 3 problems left. I'll load up problem set 3 here later on today. Print that out because that has the nice step-by-step for synthetic if you're going to lean that direction. Make sure you do that and just put it back in Dropbox on a Sunday before we come back. Questions? Any last minute questions? Anything I need to go over?
Are we supposed to do the rest of the problem set or no?
Yeah, well, we just did 4, 5, and 6. So you got 3 on this problem set. There's 3 on problem set 2, right? So you got 3 out of the 6 are done. So do the 3 now, sometime before in the next 12 days or whatever it is, download and print and complete problem set 3. There's probably about 7 or 8 problems on that one. Using one or the other method. Don't do both. You can, but you don't need to.
So our homework is just problem set 2 and 3, and that's it.
That's it. And I'll see you back on the Monday after Easter. We'll put a bow on this section that day. We'll probably do a quiz sometime that week on this section and keep on moving.
Yeah. Sir.
I'm excited.
All right?
Yes, sir.
Questions? Anything I can help you with?
No, sir.
Sure.
All right. Well, everybody have a nice Easter. Hopefully we're coming to the downhill side of this thing and we can start getting back to a more enjoyable, normal way of life, I'm hoping. I'm sure you guys are hoping that. And check in with me during office hours if you got any questions or problems, or just shoot me an email.
Sir, I'm going to turn in everything toward email. All right. Thank you.
All right. That's all I've got for you unless you have a question. Otherwise, I'll put a bow on this one and we'll see you the Monday after next. All right. Everybody have a nice Easter.
Yeah, Mr. Gaff.
Yes, sir. Mr.
Bye, sir.
All right.